Okay, so here's the Unit 0 exam review video. I'll be working on the Unit 0 review problems. And if you guys feel like you need more review, we'll have some extra exercises that we haven't done yet in this packet. The ones that are due, I hope you guys understand. I'll go ahead and type that here at the beginning. You guys need to have in homework last night was 5, 6, 7, and 8. Okay, we did most of that in class, but you guys might have had a little bit of 7 and 8 to do. Okay, tonight you guys have to do pages 17, 18, and 19. Okay, so those are the ones that we need to have you guys finish up. Make sure that you have any questions asked about that, because sometimes if you don't make it to the last problems and then you realize, oh, I don't know how to do any of those, so this would be the time to ask me these next couple of days, stop by office hours so we can make it happen. So we're going to just jump in. Let's begin by understanding the difference between the product and the sum of two numbers. Okay, it says write the product on the top. So again, that's what we get on the top. We write what we get when we multiply. And on the bottom, we write what we get when we add. Okay, so the sum is in this spot down here, and the product is going to go up here on the top. So let's begin. We'll start out by talking about this number. 4 times negative 13 is negative 52, and that's kind of an important number because it's the number of cards in a deck. Okay, so it's worth knowing that number and memorizing it. If you didn't know that by heart, it occurred to me that some of my students might have reached for a calculator to do 4 times 13, and there's no need, okay? A deck of cards is a well-known object, and you guys should know that it's 52 cards in a deck. So if I add 4 plus 13 plus negative 13, right, I add those up, understand that adding a negative number just means to subtract. So this is the same thing as 4 minus 13, right? And that's the same thing as if I had a number line, right, and zeros in the middle, and I have 4 over here, right? And if I take 13 steps, where would I be? Okay, that's the idea of what we're doing here. So when it comes to negative numbers, use the number line, okay? Don't start thinking about special rules or anything like that. You have to count, and that's really the secret sauce to doing these problems, okay? So 4 minus 13 gives us negative 9. Okay, so the next thing we're going to do is over here, we're looking at 5 times negative 5. Okay, and again, I was talking to my students today about how you don't have to reach for a calculator for this either, because we should know in our heads that 15 is 10 plus 5. And so I could break that up into 50, right? 5 times 10 is 50, and 5 times 5 is 25. So I can do this in my head by just doing 50 plus 25, right? And getting that that's 75. So again, we know that the product means that we have to multiply them. And anytime we do a positive times a negative, we have to get a negative. So always pay attention to the signs. And then when we add these up, 15 plus negative 5 gives us positive 10. Okay, so just don't forget that 15 plus negative 5, right, the sum of those two numbers, this is the same thing as 15 minus 5. That's all it means. It's just 10. Okay, so we got to be clear about that. So why don't you check your own understanding and see if you can do 3 and 4. This would be a good time to pause the video and try to do that part and check the answers when we're done. So now, hopefully you see that a negative times a negative is a positive, and 8 times 3 is 24. And then now we do negative 8 minus 3. Okay, you got to fight the instinct to say that that's 5 and realize that, you know, if I spend $8 and then spend $3, I just spent $11, okay? So I like to think of negatives as spending money, because it's just like real life. It's the same way you'll think about it when you have to pay your bills. Those are negative. Okay, so now we got to do 6 times 15, and I wonder if you're going to reach for a calculator for that. Maybe we could do that the same way we did the other one, right? Using the distributive property. That's 10 plus 5. Okay, so that's 60, right? Plus 30. So I can do that in my head, right? Because 6 times 10 is 60. And then 6 times 5 is 30, right? So if I add those up, I can get 90. So don't always resort to using a calculator. You guys have to practice using that muscle, the muscle memory of counting in your brain, all right? And then 15 plus 6 is going to give me 21. Okay, so digest these kind of problems and understand you have to, know the difference between multiplying two numbers and then adding it, right? Totally different, okay? When you're adding, it's actually more scary to me because you're gonna have a tendency to believe you know the answer. So always think about where 0 is and, use the number line. It's on the board. Counting is the real way to do this problem, and the number line can help you stop any mistakes. Okay, so now we'll get out of this section and we'll move down to the operations with fractions. Let's try to get through these. I think I could probably zoom in a little more. So for this example, we can see we don't have any with the same denominator, right? Notice that these denominators are different. So I'm not allowed to just go combine the tops, right? We have to do something, right? So in this case, the way I teach my students to work is we copy our blank parentheses, right? And then I put an empty fraction there. And then I'm going to write 7 over 2 minus. Sometimes I'll do it like this. Every now and then I might put the empty fraction on the other side, but this is good enough. Okay, so notice we copied everything, but right in here, right, and right in there in before those values, I added that right in there, okay? Just a blank fraction. So we have to know is that 7 is not a multiple of 2. And I'm hoping that already made sense, right? If there was a multiple of 2, I wouldn't have to change both of them. But because there's no way I can multiply 2 times something and get 7, and there's nothing I can multiply 7 by to get 2, we have to change both of these fractions, okay? So the way we did this in our fractions review would be that on this fraction, I'm going to put 7 over 7, okay? And I got that 7 right here. Okay, so now to figure out what number goes in this spot, I'm going to look at the other fraction at the bottom. And I see the denominator was 2. So I put the denominator right there, and we make that happen. The next thing we do is we multiply out the tops and the bottom so that we can combine everything. So we have on top, 7 times 7 is 49. And on the bottom, 7 times 2 is 14. And we got minus. Then for this fraction, we have 2 times 9 is 18. And 2 times 7 is 14. Notice that these are both over the same denominator, and that was by design. Okay, that shouldn't feel like an accident when you're like, hey, they ended up the same. Okay, we wanted them to end up the same on purpose, right? And that was why we made sure this one ended up being 7 times 2, and this one was 2 times 7, right? To make sure that we get the same symmetry so that they both have 14 on bottom. Okay, so now 49 minus 18. Okay, you guys can do that calculation and understand that that has to go on top of the fraction. Okay, and the thing about using a calculator for everything is every now and then your finger will slip and a button won't really have been hit correctly. And if you just believe your calculator, you might be unpleasantly surprised when you get your test back and realize that there was a problem that was wrong, okay? And that's on you, actually, okay? You have to know that the calculator is just a tool. You can't blame it on the calculator, all right? So for this one, we should observe there's no common multiple. I cannot turn 3 into a multiple of 7. I can't turn 7 into a multiple of 3 yet. So what we're going to have to do is we'll have to change them both. So I copy that first fraction, give that blank, and then copy the second fraction. And we got our 2 blanks. Okay, what numbers go in this one? Okay, well this one will be a 7 over 7. Again, I got that from right here. How do I figure out what numbers go here? We look at the other denominator. That's 3, right? So I want this to be 3 on bottom, and so we also have a 3 on top. So we do the top times the top, and this will give me negative 28, and on bottom we have 21. Okay, but here we have 3 times 6, which is 18, and on bottom we get 21. So we can add those up, okay, and then think about what this means. We have 21 on bottom, but on top we have negative 28 plus 18, okay, and we can combine the top because they have the same on bottom, okay. But negative 28 plus 18 is negative 10 over 21, okay, and there's no factors. This number is irreducible, right? It's irreducible because there's no way we could break it down. If I tried to break it down, right, this is like negative 5 times 2 over 7 times 10. You see all these numbers are prime now. I can't break them down anymore. And they don't have anything in common, right? So we would say these numbers are relatively prime, and therefore the fraction is irreducible. So we can walk away from there. Okay, I'm going to get rid of this work, and if you need to bring it back, obviously, you can rewind the video. So we're going to move to 7 and 8, and then we're almost out of fractions after this. So again, when we multiply fractions, we do the top times the top and the bottom times the bottom. So 27 times negative 2, is that going to be positive or negative? The top will still be negative. So have a negative, and we'll get negative 54. Okay, on the bottom though, we have 7 times 7, and that gives me 49. Okay, and these numbers are relatively prime. As we can see, the only numbers that are hiding inside of 27 are 3 times 3 times 3. So there's just a bunch of 3s and 2s on top. And on bottom, we only have 7, so there's nothing that could be broken down out of here. So this is irreducible as it is. And now we can work on this one, okay? You guys might have figured out by now that I really don't like giving you guys steps to follow blindly, okay? So I'd like to kind of focus on understanding, but there's something a lot of teachers say, and that is copy, change, flip, okay? One reason why I don't really like recipes for this is you should understand why we're doing it, okay? So I'm just trying to say that if all you understand is how to do it, you should still have a conversation with me about why this works, and there's still more understanding behind this, okay? So the first thing we do is copy, and notice I copied 7 eighths, all right? So that's me. I copied it right here. That's the copy step, okay? So that's copy. Get it? Now we're going to change, okay? So the change is going to be where I take the division sign and I change it into a multiple, okay? We change it to multiplying. Then we're going to flip. We take the other fraction, and instead of doing 10 over 9, now it's 9 over 10. And that's it, okay? So the sentence I usually tell my students is that dividing by a fraction means to multiply by the reciprocal. And you must have that in your notes somewhere. So now all we have to do is multiply to finish this problem. We have 7 times 9 is 63. And on bottom left, 8 times 10 is 80. Okay? So, again, this fraction is irreducible. And I hope you guys can see that on top we really only have 3 times 7. There's no numbers to take out of there after that. And then 80 is 2 times 2 times 2. I guess it's 16 times 5, isn't it? So 2 times 2 times 2 times 2 times 5. There's nothing in common on top and bottom. So therefore, this is irreducible. And that will be the end right there. So let's now, we're done with that. So let's move on. Okay, I'm going to mention one thing here is I do talk kind of slow in these videos. The first video I think I made for my classes was a pretty long, hour-long polynomials test, and I noticed that when I told my students to watch the subtitles that I was talking too fast. And so I've been trying to go very slow so that anybody could watch this with subtitles if they needed to watch it in a different language. So I highly recommend you can also watch this maybe, you know, dare I say, in another class if you have a down moment. You would be able to watch this on YouTube, hit the captions, and kind of pay attention to the video instead of just, instead of only being like listening to it, right? You can watch the subtitles and be able to read the captions, so you can turn the volume down and not bother anybody, right? So it might be a good idea to keep that in mind, right? So now let's do order of operations. So in this case, we're doing order of operations, and we have seen before, I think I'll actually, you know, I could refer you guys to my other video. I was about to do everything, but if you need order of operations review, you should go watch that video where I did the whole thing more slowly. We'll start off by just kind of looking at PEMDAS and then basically remembering that it's not PEMDAS anymore, okay? Those were maybe like the 90s or something. Okay, now everybody's using GEMDAS, okay? And that's because the G stands for grouping symbols, and we realized that there's more, right? For instance, this is a parentheses, right? But what are these things called? Okay, those ones are called square brackets. Okay, and those are also a grouping symbol, right? So, I mean, why are we saying only parentheses when there's other examples, okay? We also have another grouping symbol that I taught you guys this year, which was the square root. So we want to get away from calling them just parentheses because as you guys move up in math, there's a lot more to see than just parentheses, all right? So in this problem for number 9, we know that we're just going to copy everything except the thing that's the highest in the hierarchy of operations. Okay, so the highest thing in the hierarchy here is grouping. There's no grouping symbols, right? So now we get to the next one, which is the exponents. Okay, and we see an exponent right here. The exponent is the 2. So that little 2 means that I have to do 3 times 3, right? So don't forget the 3 squared. You might think that that means 6, okay, but it doesn't mean 3 times 2, and it doesn't mean 3 plus 3. It means 3 times 3, okay? And so that gives us 9, of course. So we're going to write 9 right here, and then that's plus 13. Okay, now here we go. We got 10, and then we got minus 2 times 9, but 2 times 9 is 18. And then we have that plus 13. Okay, so 10 minus 18 will take us 8 steps to the left of the 0, right? So we'll be at negative 8, and negative 8 plus 13 is going to take us back over to positive 5. So that would be the end of that problem. Okay, for this one, we have 2 grouping symbols. Not only do we have these parentheses, but then we have these ones too. So we want to start on the innermost parentheses, so I would have to start in this one, and then I'm going to move inside to that one too now. So that means I'll copy everything, and then when I get to this parentheses, I have to go put in the answer to what I get from negative 5 plus 1. Okay, and negative 5 plus 1 is negative 4. So when we do this, we have negative 4 divided by 2. And what does that give? That gives us negative 2 cubed minus 7. Don't forget about this little exponent up here. Right? That's important. So to cube something, what does that actually mean? Well, to cube some number means to multiply it by itself 3 times. Okay? So if I was saying let's do 4 cubed, okay, that just means 4 times 4 times 4. Okay? It would be 16 times 4, so we would get 64. Okay? But this says negative 2 cubed. So that means I have to do negative 2 times negative 2 times negative 2. So let's write that. If I have negative 2 cubed, then notice the negative is in the parentheses. And that means we're doing negative 2 times negative 2 times negative 2. But negative 2 times negative 2 makes positive 4. And I still have to do that times the negative 2. And a positive times a negative makes a negative. So 4 times negative 2 is negative 8. And we end up with negative 8 minus 7. Negative 8 minus 7, well, think about it. If you spend $8 and then spend $7, how many dollars did you spend? You spent $15, right? So it's negative 15. So again, avoid falling for the false answer, right? Where you said that 8 minus 7 is 1 or something. And just take a look at the number line so that you know what to expect, okay? It's kind of important to estimate before you calculate, right? If I do this, I could look at it and say, okay, I'm going to get a pretty big negative number because they're both negative. And then if I go do my math and count wrong, at least I can kind of compare that with what my expectation was, and I could realize something's wrong. So now we're moving a little farther along. We got this first one done, right? So we can say goodbye to that page, and we'll get on this one, okay? I did number 11 in class, so I think we could do this one right now. We'll do number 12 as the last one here. Okay, so for order of operations, again, we want to try to get this one to begin with the grouping symbol. Okay, well, the grouping symbol is this parentheses, and 3 minus 7, the 7 is bigger and it's negative, right? So that means we'll have negative 4. Okay, and then we'll square that, and we'll put plus 11. Negative 2 plus negative 1. Okay, here we go. So now we go to the exponent. Again, back to the PEMDAS. The parentheses are done. This is the only thing we have is negative 4. There's nothing left to do with that inside of the parentheses anyway. So now we just use the exponent. So negative 4 squared means, what does that mean? Let's think about that. Negative 4 squared. Well, that means negative 4 times negative 4. And a negative times a negative is always a positive. So that means we're going to have positive 16. We have plus 11. And on the bottom, we have negative 2 plus negative 1, which means negative 3. And if we put these together, we get 27 divided by negative 3. Okay, and we know a positive divided by a negative is a negative. So we'll get negative 9. Okay, so if you have any questions about any exercises we went through, or if I made a mistake or something, you can feel free to email me, and we'll get to the bottom of it. So we're done here. Let's move on to the next set. And I was hoping that this video would be less than a half hour, and I'm not sure we're going to get there, so bear with me here. I might start to rush a little bit. Okay, I'm sorry if it feels that way. I might not do every single problem, but I'll definitely do most of them. So I'm going to make this full screen and we'll begin. So when we talk about points in the coordinate plane, you guys want to remember that we have x and y coordinates, okay? We call this an ordered pair. So it's a kind of object, okay? It's when you take two numbers, and whenever we give a special meaning to the first one and the second one, right, when we care what order they come in, we call them an ordered pair, okay? So the way this works is that the first number is always your x coordinate, okay? So the first number is always x. That's just the way that it works, okay? That's our x coordinate. The second number is always the y coordinate. Okay, and as you move through math, we change some of the names of these ideas, the y-axis and the x-axis. Sometimes, for instance, we'll use time, right, as we've been doing in some of our problems here. And when it's time, that won't be the x-axis, it'll be the time axis, it'll be t, okay? So that happens every now and then, that you use t instead of x. So just get used to that. It's the same idea, though. It's just a point. So if we do this first one, I'll do this in blue and we'll label it. So the way I teach my students to plot a point would be start in the middle and then figure out where I want to go on the x-axis. It sends me to -4. So I'm going to go to -4, so I'm right here. Now I want to know, do I go up or down? Okay, and since it says 2, positive 2, I know that means I got to go up 1, 2, and I'm going to put my point right there, and that is my point. I'm going to erase everything else that was just there for you guys to see. Okay, so again, I start in the middle, I go left 4, and I go up 2, and I put my point there. And I'll name that B. Okay, so let's do the rest of them. Okay, well, to get E, I'm going to go right 8, and then do I go up or down from here? Well, it says that y is 5, so now I'm going to go up to 5 right here, and I put the point there, right, for E. All right, now we're going to get G. So for G, it tells me to go to -5. So I start off by going -5 and then decide to go up or down. I'm going to go up, and that's our point right there for G. Okay? So now we have this one, L. Well, we got 8 and -4. So again, we see that I go right to 8. Yeah, it's my x coordinate. Now I decide, do I go up or down? Well, I had to go down 4 because that's -4. So I should be right there. So we'll call that L. Okay, I'm going to do one more. I'll do half of them, and you guys do the other half. Okay, so we have this Q point right here. Well, it tells me to start in the middle, and then I go to 3, and then do I go up or down? I'm going to go down right here. One step to this point right here. And so there we have it. The point is Q. So you can continue to get the rest of them. I hope this makes sense to you. Pause it. I'm going to plot these points to make sure that I'm sure I have everything in this video. But why don't you do it ahead of me, okay? Here we go. I'm going to switch to green, and let's put all these points in green. So we'll start with this one, okay? Again, I'm starting in the middle, and I go left to -2. And do I go up or down? Go up to 5. Okay, so let's go put that -2, 5. We call that X, okay? I guess I could go a little faster maybe. So S is 4, 6. I'm going to go to 4 and then down 6. And we'll call that S. Okay, we got D is 2, negative 2. So I'm going to go to 2 and negative 2. That's D. Okay, we got A is negative 7, negative 5. So I'm going to go left 7. And then I have to go down 5 to get to A. And I got M over here, 6, 0. So that means I go right 6 and then I don't go up. I go up 0. See? Since it's not 0, I don't go up, and that means it literally stays right there, stuck to the x-axis. Okay, and I guess I could name that point M. Okay? So I'm going to move on to the next part. The video's going to run a little long, but we're getting there. We're almost at the end here. Now we'll do this next little set that has to do about labeling once they've already been plotted on the coordinate axis. So I won't do all of them. It's going to take way too long if I do all of them. I want this video to be a little short so that more people are encouraged to try to chip away at it. Okay, if you watch this over 2 days, you'll probably be totally reviewed and ready to go. So we'll get M. Okay, I can see M, the coordinate for X is 4. Okay, I could see the coordinate for Q, right? The X coordinate for Q is negative 4. Okay. What's the x coordinate for W? The x coordinate for W is 2. Okay, what's the D coordinate for, the x coordinate for D is 1. And the x coordinate for A is negative 5. We can see the x coordinate for N is 7. See, okay, so I just did a bunch of x coordinates to try to make sure you guys could get those. Now let's do all the y coordinates. Okay, so M, okay, I see M has a y coordinate of 5. Okay, D, I see D has a y coordinate of 2. Q has a y coordinate of negative 3. Okay, A has a y coordinate of 6. Okay, I hope you guys can see what I'm doing. I'm following my way over to the x-axis. Okay, N, test yourself. What is the y coordinate of N, right? I'm going to follow myself over to the y-axis, and that's a 4. Okay, again, the reason why we call this the coordinate plane, the rectangular coordinate system, is because when I want to find the coordinates of a point, I get its x-coordinate line, and I get its y-coordinate line. To do that, I have to do what kind of angle? I have to make a right angle. And because this becomes a rectangle, okay, we call this rectangular coordinates. All right, so there's another name for it. We also call it the rectangular coordinate system. And some people might just call it rectangular coordinates. Either way, you guys need to know this. So complete the next part. Okay, those last 6, I'll leave those for you guys to make sure you can check your understanding. And so now we have, I think, only the last page. Here we go. So to get through these Pythagorean theorem problems, the first thing you want to understand is that I am looking for the missing side of a right triangle, okay? So I need to notice, 1, I have a right triangle. And 2, I know 2 of the sides, and I want to find the third one, okay? This is when you use the Pythagorean theorem. I have other videos on this if you want to go check those up. If this is something that's has you struggling, just go ahead and watch the other videos on the channel about this, and you can key in on it a little more. But I'll do a few examples in this video, okay? So we only use the a squared plus b squared in this situation, okay? This is really useful when I know 2 sides of a triangle and I want to find the third one, okay? So you might want to write that in your notes because that's the thing that you actually have to remember after you leave this class, okay? This is something useful in all different levels of math. You always kind of have to come back to this, okay? Now what I taught you guys is we look at a right triangle, and I'll draw this for now, and I taught you guys the parts of a right triangle, okay? I taught you guys the leg and the leg. Those are the 2 that make the right angle, okay? And then I also said that the side that doesn't make the leg, right, is called the hypotenuse. That's kind of a crazy side. And so that's basically the C, okay? The A and B will always be the legs, and the C is always the hypotenuse, okay? So I hope you guys understand that this procedure is something you got to get really used to. Okay, so what I usually tell my students to do is darken the 2 sides that make the right angle. Just darken them, shade them in so you don't miss it. and those are your A and B. Okay, so if you can hold that together, you can at least set up the problem. So I could put A here, and I could put B there, and that's fine. So we'll write 9 squared plus 17 squared equals what? Well, my C is over here then. Okay, so we'll do equals x squared. So notice I just changed all the letters to be all the numbers that were on the page. Okay, now we get 9 squared is 81. And then you want to get 17 squared. In this problem, you won't be doing with the calculator. Okay, so you need to have a calculator for this on the test. And then if we do 17 times 17, we get 289, right? That's 17 squared, so don't write 34. That's not what it means. Now I want to add that with 81. We add those together, and we get this value 370. And that equals x squared. Well, to solve this, as we learned in class, I'm at the last step here, okay? So we multiply these numbers by themselves. We added them up, and now we just want to take the square root of both sides, and that happens in the calculator. Okay, the whole point of taking the square root was to get x by itself. Okay, so that's a big idea. It's a huge idea. I'm going to put a little mark by that right now, okay? Big idea, okay? The idea is that the square root is the inverse of squaring, okay? So I'm just going to write x squared. So this is the square root of x and x squared are inverses of each other, okay? They're opposites. So we have to go into our calculator to do the square root of that. And we get 19.23. But if you notice up here, it says to round to the nearest 10. So we'll use our approximately equal sign. And then I want to clean that equal sign up a little bit. Okay, we get 19.2, okay, again, because that 3 was less than a 5, so when we round to the nearest 10, we just stay at 0.2, right? This is closer to 1920 than it is to 19.30, right? Okay, so this problem is done. That's an example of Pythagorean theorem. This is something you want to be prepared for. Okay, so we'll try this next one on the side over here. Again, the first stop is to notice I have a right triangle, and do I know 2 of the sides? Yeah, I do. And do I want to find a third one? Okay, this is literally like one of the only situations you want to use this theorem then. Okay, so we're going to write a squared plus b squared equals c squared. Okay, now what do I do? Okay, I told everybody darken the 2 sides that make the right angle. That's your a and b. Okay, it doesn't really matter which one's which. It just matters that they're A and B and that they go together on the left side of the equation, right? Or on the same side of the equation either way. So I have x squared here, and here I have 11 squared. Get it? Okay, but what goes for C? Well, that's my A and B. So then C is over here. So that means we have 14 squared right now. Okay, so we can finish up the math by doing x squared plus 121. Okay, plus equals 196, right? Okay, and then what do I want to do? Okay, I want to find the x. I mean, do I want to take the square root right now? What's really happening? So you want to always understand, I want to find the answer, right? I want to find the number that makes this true. That's what it means to solve an equation, right? So we have to take away the 121 from both sides so that we can make this into a one-step problem. Okay, now it's actually a one-step problem because we have this idea of x squared equals 75. So now what I can do is take the square root of this side and that side. Okay, and the whole point of taking the square root was to get the final answer of x. And over here, we have to take the square root. Now you can do this in your calculator and get the square root of 75. Later on, we'll learn how to reduce that and all of the algebra that comes with a number like that. There's a lot to learn, okay? But the point is that you should at least have 8.66 and then the approximately equal sign of 8.7. So this is a big difference, okay? Notice the difference. In this problem, we wanted to find the hypotenuse. You get that? But in this problem, you wanted to find the leg, right? But in this case, I had to find the C. I had to find the hypotenuse, okay? There's a big difference, and that's why I tell you guys just darken the two that make the right angle, and those two should be on the same side of the equation together. Those two go together. All right, so we'll try it a little bit more. The video has run very long, and so I feel like we're getting to the point where I'll skip 17, but I will take a look at 18 in case we get there, okay? The idea is that you guys should see that if this whole thing is x, right, then this piece is equal to that piece. So if I find this missing one, I could just double it up there and add it up to get x. So that's all you have to do is just go ahead and solve this problem as you would, and then when you get this number right here for b or something, just add it up twice, okay? What I want to do now is get to this problem that I know you guys will have trouble with. So I'm going to skip those two because this one is more important. So let's take a look at both of these and we could draw the diagram that we have here. Okay, so an Olympic-sized swimming pool is approximately 50 meters long by 25 meters wide. Okay, so it's telling us that we have a rectangle, okay? And it's saying that that's 25 by 50. Okay, and it says what distance will a swimmer travel if they swim diagonally from one corner to the opposite corner. So if he starts here and swims over here, how far is that? How long is that red line? Well, if you see what we got, right, they're saying this is a rectangular swimming pool, and so if this side is 25, the other side is 25. So look, we have a right angle, okay? Also, inside of the problem is kind of, you know, if it says to the opposite corner, we know that there means that they have corners, and therefore it is a rectangular swimming pool. So we want to find the length of this side, and that's like my x or my c, if you will. So I could put an x right there and try to find that, and then we could use our formula. A squared plus b squared equals c squared. Well, again, look, my a and b are the two that make the right angle, and that's 50 and 25. So we'll do 50 squared plus 25 squared equals c squared. But again, the c in this case is my what, right? Because don't forget, this is a, right? And this is b. Okay, it wouldn't matter if I flipped them around the other way. If this was a and that was b, that's fine, okay? But what has to be is that they go together, okay? So we need to make sure that the x is the other one, okay? So for the c, we'll switch that into x, and that's what we want to find right now. Okay, so you could do 50 squared, right? That means 50 times 50. So don't tell me it's 100. It's a much bigger number than that, right? You got 2,500. Okay? And then you got to do 25 times 25. Okay? Which gives you 625. Okay, those are good numbers to memorize because when it does come to squaring big numbers, those numbers do come up a lot more because we know you're familiar with them, right? Okay, so if we add that up, you guys got 3125. I think that should be understandable, but now I have to take the square root of both sides so that I can solve this. So we add the root here, add the root there, and then we just go calculate. I got 55.90. Okay, and so if we round, that's just 55.9. Okay, so you can see the hardest part of this problem would have been you looking at it and feeling that there's something you could do, something you know about it. In this case, it would be the right triangle. So I want you guys to really connect this idea, right? This formula is directly connected to the idea of distance, and this is why we teach you guys this so much, because the distance between things is very important in lots of different ways, right? Let's get back to number 2. So, sorry, number 20. We'll do this last one. Okay, so in this case, it said 20-foot ramp is used at the loading dock of a factory. Okay, a ramp, you got me? So that means that it's something slanted, right? So we have the ground, right? We know there's a ground and we know there's a ramp. Okay, and it says it's from the base of a dock. So there's like a loading dock, right? Which means like that there's like maybe a truck parked down here or something like that, right? We got this big truck, but then maybe there's like a platform that's lifted up, and then up here is where like we actually load the things onto the truck or something, right? So this is the situation they're giving us. And basically, it's asking us how high is the loading dock. So it wants to know this right here, right? That's what it wants to know. Okay, and then it gives us a couple things. It says a 20-foot ramp is used. Okay, well, if this is a 20-foot ramp and this is the ramp, we know what a ramp is. It's this at an angle. So that is 20 feet. So it wants you to label it like that. Okay, and then it says that the base of the ramp is right here, right? That's the base. This is the top of the ramp, right? You start here and you walk up it, right? So if that's the base, and it says that the base of the ramp is placed 19 feet from the base of the dock, then this distance is the 19 feet. Get it? We're saying that the base, from the base of the dock over here, has to be 19 feet. So we need to find, is this distance x? We're trying to find that value right there, okay? And it's just a right triangle. So all the words are just extra. And the truth is that we really just have to draw a right triangle and solve it using the Pythagorean theorem. So tell me, check your understanding. What do you think A, B, and C are? Okay, check your understanding right here. What are they? Well, I've been telling you guys A and B are the legs of the triangle, and the legs of the triangle are the two things that make a right angle. So I could call this A, and I could call this B. Okay, so I'll write x squared plus 19 squared. Get it? A turned into x, and B turned into 19. Okay, and since this must be C, the last thing over, C is going to turn into 20. Okay, but now notice that all the numbers are squared. Okay, so don't let that part fool you. So now we have to do 19 squared, another number that does come up kind of a lot. I know you might feel like the times tables are good if you know up to 12. It can save you some time to know these ones. Okay, so we got 361, and 20 times 20 is 400. So what do I want? I want to get x, right? But I don't have x. I have all this other stuff in the way. I have this 361, so I want to get rid of that. Okay, I want to eliminate that. And if I do eliminate it, what I'll have is a one-step equation. So I took away the 361 so that I would have x squared by itself, but now we have to do 400 minus 361, and that gives me 39. Okay? I believe this problem would probably want you to round to the nearest tenth, as we did before. So if I take the square root of this and the square root of that, we get x equals square root of 39, and then I just have to calculate that. Okay, and we should expect more than 6, which is something I'll start talking about more, is that we do have to estimate these values in our head a little bit so that we get a sense of what they are. So I have 6.24, okay, and then we have to round to the nearest tenth, and because that 4 isn't big enough, we can stay at 6.2. Okay, I knew the video would run a little bit over, but this is how it is. So I really do hope that you guys could get through this. I'm trying to think if I left anything else off. I guess you'll need to know the circumference of a circle, and I believe I did make a video about that. So if you're worried about that, go watch that one, okay? And you also do want to remember to memorize that list of decimal formulas I gave you that show you what everything is equal to, such as like 1/5 being equal to 0.2, that 1/4 was equal to 0.25. You want to know all of those, especially when it's one of them, right? The 1/8 was 0.125. The pattern, that 1/9 was 0.1111 repeating, all right? And that 1/10 was 0.1, right? And then we got farther, all the way to 1/16 was the last one I had you do, and you learned that was 0.0625, and so on and so on. Okay, so there will be a little bit, you'll have to do 6 of these on the test. Okay, I'm not going to tell you which ones, but if you have these memorized, you should be able. Okay, we're going to let there be calculators on this exam, but there will be no notes. Okay, so you got to make sure you guys actually know this, so no notes involved. Okay, and then I guess you'll also want to know the speed formula, right? The speed formula that we use, because there will be one planet that you'll have to calculate on the test, and that's what we do. Speed is distance divided by time. Okay, I'm gonna cut this video off before it ends up being 45 minutes long. Okay, I hope you guys can watch the part you need. Good luck studying.